Math 3, Unit 4. Today we're talking about rational exponents. So I don't know if this is obvious or not today, but we're going to be talking about exponents. Exponents, also known as powers. Yeah, good. You did. And so how this works is that if you have, and you guys can maybe, in your books, maybe see this better, but this says the nth root of x. You can write that as an exponent. The index goes to the bottom of the fraction for your exponent. So your exponent will be a fraction. And if you have an exponent inside, like for instance, x is really to the first power, it ends up being x to the 1 over n. Okay? And then these can go back and forth. So I think it's easiest if we just go ahead and start doing examples. So here we go. Example A. So we're going to switch this from exponent form into radical form. And so again, this bottom number is always your index or root. We can call that a root either way. And then the 1, that would be your power for that number. So when I rewrite this, it's going to be the cubed root of 64. And we don't have to write 64 to the first power because, exactly. And then we can simplify this from this point. So can 64 break down? So 64 breaks down to 16 and 4, and 16 is 4 and 4. So my answer ends up being 4. Right? Because there's 3 fours?
Yeah.
Okay. Okay. Do you guys, so as kind of like a little side note here, when if I have something like x to the second times x to the third, what does that end up becoming? X to the fifth. So what did you do with the 2 and 3? You added them, okay? So here, do you see how these are both base 11s? And you can only add exponents if you have the same bases, like just like here I had the base of x. So we're going to go 1/2 plus 1/2. And what's 1/2 plus 1/2? Good. It is 2 over 2, which reduces to 1. And 11 to the first power is really just 11. So I kind of showed a lot of work there, but again, I like to show more work in notes so when we look back, we know what's happening. Okay, so what do we have to do with C? Get the same base, exactly. And so what base do you think we'll end up using? 3. And so this one is already 3 to the 1/4. And so 27, how can I change that? Three to what power? Third. So since this is 3, it's probably that I'm going to make that a 3, okay? And so 3 to the third power is 27, but there's already a 1/4 there. So what you do is powers to powers, you multiply. And so that means I'm going to end up multiplying 3 over 1 times 1/4. So to rewrite this, I have 3 to the 1/4 power times 3 to the what? 3/4. And then I can add my exponents. And so we end up with 3 to the 4 over 4, which reduces to be 3 to the first, which is just 3. Okay? Any questions so far? All right. D. So it says write each expression in radical form. And so this one we're going to go put these in radical form. So what would be my index on D? 8. So we have the 8th root of w to the 5th power. Another way that this could be written is the 8th root of w and then the whole thing raised to the 5th power. Both of those mean the same thing and both are acceptable answers. Colton, you getting all this? Okay. All right, what happens when you have a negative exponent? Yeah, you have to change the side it's on. So right now, since I have -3/4, this is over 1. And so in order to get rid of this negative exponent, I'd have to take this whole thing, because the whole thing is being raised to a negative exponent, and bring it to the opposite side, so to end up coming to the denominator. So that means I have t to the 3/4 in the denominator, and if there's nothing on top, it's a 1. So if I were to rewrite this in index form, this would be what? Good. 4 through to t to the third over 1. Okay. Is this acceptable to leave my answer like this? No. Why not?
Can't have roots in the denominator.
Very good. And so in order to make a group here, how many more t's do I need? 1, right? Because right now I have t to the third, and for a group, I just need 4, right? And so I'm going to multiply by the 4th root of t, and whatever I do to the bottom, I also have to do to the top. And so this makes a total of 4 t's, because I have 3 plus 1, which makes 4. So that means my denominator now is what? T. And then 1 times the 4th root of t is just the 4th root of t. And so that would end up being your answer. Okay, if you have a decimal, I would probably end up changing that to a fraction. Okay, so that we know the correct index and stuff. So how could I change 1.2 into a fraction? Close. I'm going to show you what I think would be the easiest way. Okay? So what decimal place does this go out to right here? The tenths. Good. And so since it's the tenths, that means it's 12 over 10. You take that number and you put over 10. If there had been 2 numbers after the decimal, then I would have ended up putting that number over 100. So whatever decimal place you're going to. And then can that reduce? Yeah, so I would go ahead and reduce that. So that's going to be y to the, good, 6/5. Okay, and so if we change that into root form, how will I write it? The 5th root of y to the 6th. Can that be simplified at all? Because how many y's do I need for a group? 5. So that's going to be y to the 5th is a group, and then how many y's do I have left over? 1. And so we write that as what? Perfect. Y 5th root of y is the correct answer. Any questions? Yes?
Could you have just made the decimal fraction and use that?
The decimal, say that one more time.
Could you just make it into an improper fraction and then use that? Would that still work?
Yeah, would you get the same answer?
Yeah, except it was relative to instead of 5.
It was with a 2 instead of...
Oh.
So you wrote it as like 1 and 2/10?
I wrote it as like 3 over 2.
3 over 2 is not 1.2. You did, okay. Yeah, so you could write it as 1 and 2/10, which would reduce to 1 and 1/5, and then change it. Okay, so are we good? Are we good now? Serena, are you good? Yeah. Okay. All right, next one. Okay, so now they want us to write each expression in exponential form. So we're going to change it from root form and then just write it in exponential form. So what number goes in the bottom of the exponent? Good, your index, the 4. So this is x to the 3/4. Can that reduce at all? No, that's my answer. Okay, do h. Okay, so this would be 10 to the, and I don't know why I wrote x, but 10 to the 1/2 is correct. Okay, this next one, there's a couple ways of doing this one, but to start, let's just change it to exponential form since that's what they told us to do. So how would I write that?
5xy to the 6 over 3.
Perfect. And can 6/3 reduce?
Yes.
To what?
2.
2. Good. So that means I have 5xy to the second power. And then what can I do? Distribute. You can simplify. Since there's no pluses or minuses here, the second power just goes through. But you could still write it twice if you want to multiply it out. But so that means we have 5 squared x squared y squared. And 5 squared is?
25.
So we have 25 x squared y squared. All right, questions? Okay. Yes.
So if you ever get something in parentheses like that and then you get an exponent outside, you have to distribute?
Only if you can kind of, yeah, you should normally distribute and simplify it. Yeah. Okay. So there are a bunch of rules of exponents, and most of them you know, and we've kind of talked through some of these already. But remember that when you're multiplying, you add them. If you have powers to powers, you multiply. If you have an exponent on the outside, it actually goes to both of them that are inside the parentheses, right? If you have a negative exponent, it changes sides. If you're subtracting two exponents, you know, you can, if you have a fraction like that, you're subtracting the two. And all these go back and forth, right? Okay, so all those rules are there for you to go back and reference later. Okay, so it says right here, if you recall from lesson 6-2, that you simplified products or quotients involving radicals only when they had the same index. So remember how they had the same index and the same number underneath the root, okay? However, you can combine some radicals with different indexes if you convert them to the same exponent, so that they have the same base. So like when we're adding fractions, they just have to have the same denominator, right? And we know how to change denominators. So basically, it's easy to change indexes because we basically are just changing denominators. You with me? Okay, so let's change this first, because looking at it like this is difficult, but if I change it to exponential form, it's easier. And so this root 3, what would that change to if I was changing it to exponential form?
3 to the 1/2.
Exactly. Okay, so 3 to the 1/2 times, and then the 4th root of 3, I can change that to be what? Good, 3 to the 1/4. So what would be my common denominator on this? 4. So normally, you're always going to go with the largest number as long as the smaller number will evenly go into the larger number. And in this case, it does. So my denominator will be 4 on each of these. And so here on the top, what times 2 equals 4?
2.
Good. And whatever we do to the bottom, we also do to the top. So I end up with 2 over 4. This one already is a 4, and so I just keep the 1. And so when I add those together, I get 3 to the 3/4, because we just add the exponents. So now that you have the same denominator, you add the numerators, or the tops, and keep your denominator. They're not that bad, right?
Not anymore.
All right, so B. Okay, so first thing, let's change these to exponents.
Yes.
Okay, so on the top, I have x to the what?
3.
3 over, nope,
2.
2. Remember, if it doesn't say, it's a 2. Okay, on the bottom, it's going to be x to the what?
2/3.
Good. Okay, so instead of keeping this as a fraction, when we have a fraction and we're going to combine them, what do I end up doing with the exponents? Okay, we subtract. So I'm going to have x to the 3 over 2 minus 2 over 3. Is that okay?
Yeah.
Okay, so what would end up being my common denominator?
6.
Good. So I'm just going to write this with 6's in the denominator. And so on this first one, I'd have to multiply 2 by 3. So that means I multiply 3 by 3, which is 9. And here, 3 times what makes 6?
2.
2. So 2 times 2 is 4. And so we subtract, and I get x to the what? 5 over 6. Okay, you guys try C on your own. Okay, looks like most of you got it. So what's the first thing I'm going to do? Good. And so in this case, my common denominator, and if you wanted to, we're going to end up going 4/3 plus 5/6, right? Because we're multiplying. And what would be my common denominator? 6. And so this one we have to multiply by 2. So 4 times 2 is 8. And then we're adding 5/6. And so we end up with 13 over 6. Okay, we're just going to leave like that for now. All right. We're good? Okay, next one, D. If we are dividing, this is the same thing as y to the 3/5 over y to the 4/10, correct? Okay, you don't have to rewrite it this way. I just want to make sure that you understand that these are the same. Can 4/10 reduce?
Yes.
So since I see that this reduces, I'm going to reduce it to 2/5 because when I do that, do I have to get common denominators now? No. So we end up with y to the what? Good, 1/5 is right. So I'm just going to write this out though. 3/5 minus 2/5. And so we get y to the 1/5. And that is my answer. Okay. E. What am I going to have to do with that exponent on the outside? Very good, distribute it. And so this 1/2 goes to everything. Now, 25 to the 1/2 power, do you guys know what that is?
5.
It's 5. So it's up to you on how you simplify that. If you want to, we can just write these all out right now just to kind of show the process. So let's start by writing this as 25 to the 1/2. And then when I have x to the 16th, I'm going 16 times 1/2, which is what?
4.
8 is correct. If you need to write it out, 16 times 1/2, you end up with 16 over 2, which is 8. Okay, going to the bottom, we have 9 to the 1/2. And then it's going to be y to the
16.
No.
4th.
Yeah.
So 8 times 1/2.
Yeah, same
Okay,
thing.
all right. Okay, and then 25 to the 1/2 is really the square root of 25. And what is the square root of 25? 5. So I have 5x to the 8th on the top. 9 to the 1/2 is really the square root of 9, which is 3, and 3y to the 4th. And is there anything else there that can be simplified? No. So this is my answer. Okay, are we good? Okay, this last one I feel like is slightly more complicated, but not horrible. And I don't know if you can tell or not. Can you guys tell that those are negatives with the y's? Okay, so anytime you have a negative exponent, it needs to change sides, correct? And so this y to the negative 1/2 is going to end up going up, and the y to the negative 1/5 is going to end up going down. So I'm going to rewrite this problem. X to the 1/5 stays where it is, but then I'm going to end up with y to the what on top? 1/2. And then on the bottom, I still have x to the 1/2, and then I'm going to end up with y to the 1/5. Okay. So far, so good? Okay, so now, like the x's get to go together because they have to have the same base, right? And the y's get to go together. So let's write this out. And what I mean is that we're going to go x to the 1/5 minus 1/2. Okay? And then y to the 1/2 minus 1/5. Are there questions to that point right there? Okay, what do I need to do now? Good. And so what denominator will I end up using? 10. So I'm just going to rewrite these with 10 right here. And so 5 times 2 is 10. So 1 times 2 is 2. And then 2 times 5 is 10. So 1 times 5 is 5. And so I end up getting x to the what? Negative 3/10.
Does it have to be like that? Could you just switch it around with 3
No. Well, we can if we move it to the bottom of the fraction. Okay? Okay, so the x is taken care of. Now let's move to the y's. So again, I'm going to use a denominator of 10, correct? And so 2 times 5 is 10, so 1 times 5 is 5. And then we're going to go 5 times 2 is 10, 1 times 2 is 2. And so we get y to the what? 3/10. Okay. Everybody's okay there? So we can't have a negative exponent, correct? So that means that this is going to end up having to go on the bottom. Okay? So I would write this as y to the 3/10 over x to the 3/10. Okay. This is not an okay answer. Does anybody know why?
Because they both 3/10.
You can have a fraction as an answer, but what does 3/10 represent?
X to the third power root 10.
Yeah, and can we have roots in the denominator? No. Okay, so there's a couple ways of thinking about this, but if you want to write this as a root, you could, or we could leave it as an exponent, but I want you to see something. So x to the 3/10 is really the 10th root of x to the 3rd, correct? What do you need in order to get rid of that root in the denominator? 7 more x's. Do you notice that if I were just to multiply by x to the 7/10, do you see here we're just trying to make this a 1? And what do we do with exponents? You add them. So it's up to you if you want to write it like this, or if you're like, oh, I know that I need to make this a 1, so I just need 7/10. And whatever you do to the bottom, you also have to do to the top. And so we end up with what in the denominator? Just x, right? X to the first power, because 10 over 10 would make 1. And then on the top, you want to write that in alphabetical order. So that's going to be x to the 7/10, y to the 3/10. And that is your final answer. So not all of them take a lot of work, but some of them do. And you could have probably worked through that faster. I just wanted to make sure you understood it. Do you guys have questions or anything that you want me to go back through on that problem?
$10 is like the problem like that's going to be our extra credit question.
So no questions?